Well, before we start talking about this presentation, Brian and I would like to thank you for bull-moosing your way through all this material and getting to our last introduction video. In the beginning, remember how we asked, am I a software developer? If you've gone this far, chances are you've got what it takes.
Or you're obsessive compulsive, and you need to see more of this blue gradient.
Maybe you're just obsessed with the gradient background. So the last thing that we want to talk about in our introduction series is Bitwise operations. I'd like to say that we saved the best for last, but we certainly did not. Bitwise operations are not fun, but they're very important to understand.
Mm-hmm. So we can basically break down the bitwise operations into just a few simple statements that all logical operations are founded on. It's either an AND, an OR, an exclusive OR, or not.
Let's talk about a bitwise AND. A bitwise AND is simply two binary strings of equal length. We perform a logical AND operation on each pair. So what is a logical AND operation? Well, if both values are 1, then the output is 1. Else the output is 0. Thus, it has to be on yes and yes for it to be true. So it has to be this and this, then it equals true. So let's take a look at an example. If we take a look at these top two binary strings, and we do a logical AND operation on both, let's go from right to left because that's how the computer reads this. We see that 1 and 1 are both on, therefore the value is 1. 1 and 0, well, they're not both on, it's false. 0 and 0, neither one of them are on, it's false. Again with 1 and 0, false. Again, we see 1 and 1, that's true. The other ones from the next three over are going to be false because we have different combinations or we have two off bits.
So we can see a 1 is a statement of truth and 0 is a false statement. 1, it's true. 0, it's false. You have to be true and true. If it's true and false, that's not going to work. It has to be true and true. Now we'll look at the bitwise OR operation. Similar to the AND operation, we have two binary strings of equal length, and we can perform a logical OR operation on each pair. With the OR statement, if at least one value is 1, or if at least one value is true, then the output will be true. Otherwise, the output will be false or 0. So if we look at this example, and we run from right to left, we can see that if it's true or it's true, it's true. If it's true or false, it's still true. If it's false or false, neither were true. So it's false. So 0, 0 is 0. And we can carry all the way to the far left and see 1 and 0 is 1. So if at least one of the two are on and the other is a 0, or if both are on, either will fit the criteria and they will be true.
I also want to take the opportunity, looking at these two binary strings, to kind of explain what we mean by binary strings of equal length. Technically speaking, the bottom binary string is not the same length as the top. Because from left to right, it would read 1, 1, 0, 0, 0, 1. In order for us to do a logical operation on this, we have to make sure that both binary strings are of equal length. So whichever binary string is shorter, meaning wherever the last 1 is in the bit, we take the second binary string and we append zeros to the left until the lengths are the same. Because with binary, it doesn't matter how many zeros you append to the left because they don't count. They're all off. So this is an example of how we did that to do this comparison. So the next one we have the bitwise exclusive OR. So we take our two binary strings, we perform an exclusive OR operation on each pair. Now the difference between OR and exclusive OR is both values must be different. In the OR operation, 1 or 1 is true. But an exclusive OR, 1 or 1 is false because it needs to be two different values. That's why they call it exclusive OR. So here's an example of that. Before, when we did the OR operation, the far right bit sequence was true. 1 or 1 was true, but since now we're looking at it exclusively, 1 or 1 is false. So any situation where we have 1 and 0, they're true, and every other condition is false.
And lastly, we have the bitwise NOT operation. So this is performed on one binary string, and is not necessarily a comparison of two, and it's a logical NOT operation. If the value is 1, the output is 0. Otherwise, the output is 1. So the result will always be the opposite of the statement of truth.
Exactly.
So if we look on the far right, If it's not true, it's false. If it's not false, it's true. And so on all the way through.
Exactly. So the binary string on the bottom is the complete opposite, which is the not.
Right. And that's a very fast crash course in bitwise operations.
Yes, so this concludes the Introduction to Programming tutorial series. So thank you very much for watching.
And congratulations for making it this far.
We'll see you guys in the next tutorial.